Building a generative AI studio on consumer hardware means constructing a very specific, tightly calibrated machine, piece by piece. As of 2026, a 16 gigabyte consumer GPU is the absolute practical floor for creative AI work. Above this tier, the field opens up. Below it, results become unreliable. We are looking at a precise band of silicon: the RTX 5080, the RTX 4080, the 4070 Ti Super, and the 16 gigabyte 4060 Ti. Models requiring 24 gigabytes to run, even after aggressive community quantization, are excluded from this workflow. If a model does not fit the 16 gigabyte envelope cleanly, it is discarded. Operating at this tier requires a shift in mindset. Success relies on a rigid optimization stack. Raw compute power matters less than how you manage memory. These are not optional software tweaks. They are environmental prerequisites. Ignoring these constraints produces catastrophic, irrecoverable failures right in the middle of production. The first constraint you have to solve actually has nothing to do with the graphics card. We have to look at the motherboard. This diagram shows a side-by-side comparison of a standard workstation setup: a 16 gigabyte VRAM block on the GPU on the left next to a 16 gigabyte system RAM block on the right. When you run a massive diffusion transformer like LTX 2.3 for video, it uses a mechanism called spatial upsampler offloading. This forces a massive data load into the VRAM block, overflowing its capacity immediately. Comfy UI attempts to prevent a crash by using weight streaming. That overflow data spills directly into your system RAM. But if your system RAM is also capped at 16 gigabytes, there is nowhere left for the tensors to go. The entire system halts. To prevent the system from hard crashing during these attention spikes, 32 gigabytes of system RAM is the absolute bare minimum. For reliable video production, 64 gigabytes is the mandatory working recommendation. At this capacity, the system easily absorbs the overflow data. A 16 gigabyte GPU paired with 16 gigabytes of system RAM is a doomed machine that will fail on most video models. That exact same graphics card paired with 64 gigabytes of RAM is a fully functional studio. Hardware investments in high-end GPUs are entirely wasted if the surrounding environment cannot physically absorb the resulting data spikes. Once the hardware is provisioned, the software stack must be calibrated. Algorithmic compression is the sole technology that makes the 16 gigabyte tier creatively viable. This table breaks down the performance impact across the 4 primary quantization formats used by the community. You trade a specific amount of precision for a specific reduction in VRAM. The definitive standard for Ada Lovelace and newer cards is NVFP4 or FP8 mode. It drops VRAM consumption by up to 60% with minimal quality loss, while doubling throughput. With quantization set, you must configure Comfy UI. First, enable weight streaming to push tensors to system RAM under pressure. Next, implement tiled VAEs to handle high-resolution image generation in patches, keeping the active memory footprint small. Finally, apply reserve VRAM launch arguments to handle sudden attention spikes and toggle the Sage attention flag for memory-efficient transformer operations. The order of operations is completely inflexible. Provision the RAM, configure the quantization, enable the optimization stack, then install the models. Reversing this order produces the failures that consume entire afternoons of debugging. These techniques are the strict physics required to force data center models to operate on consumer hardware. With the environment locked, we move to the models themselves. And out in the field, these models behave differently enough to dictate your daily schedule. This grid maps the 4 operational rhythms. These models demand distinct temporal blocks of the operator's day, divided into 4 zones. The iterative tier is the active ideation phase. The creative remains at the desk, prompting in real time and adjusting based on visible results, completing outputs in under 90 seconds. The batch tier is non-interactive. Single outputs require minutes to hours. The workflow pattern is to queue a massive batch before stepping away, stretching through the night to be evaluated the following morning. The set and forget tier covers highly reliable utility processing. It runs without intervention once configured, completing multi-hour generations with 0 failures. Finally, the high monitoring tier is fragile. It carries high overhead, demands constant oversight of tensor loads, and requires immediate intervention when a process stalls. FluxDev FP8 is the primary image workhorse of the iterative tier, PixArt Sigma for direct 4K outputs, and Bark for stylized voice clips live here too. For the overnight batch tier, WAN 2.2 is the reliable choice for video, alongside Stable Audio 2.5 for long-form music beds. Kokoro long-form narration and Real ESR GAN upscaling are the flawless utilities of the set and forget tier. You configure them, cue the script, and return to a completed file. LTX 2.3 occupies the high monitoring tier. Producing synchronized video and audio in a single pass is a significant architectural payoff, but it requires manual code-based patching to survive the concatenation phase. Mastering the 16GB tier is largely a time management puzzle. You have to interlock these 4 distinct rhythms perfectly, queuing set and forget utilities while you actively iterate, and loading batch work before you sleep. The 16GB tier merges the artist and the systems engineer. The independent creative now functions as their own one-person infrastructure department. You are dynamically patching Python memory handlers, tracking tensor loads during active generation, and maintaining custom node compatibility against monthly update cycles. We have seen this specific transition before. It directly parallels the desktop publishing revolution of the early 1990s. Designers who previously specified type for dedicated typesetters were suddenly forced into complex digital management. They became responsible for PostScript troubleshooting, precise font management, and strict color profile calibration. The designers who thrived in the 90s were those who treated the technical layer as part of the craft. That exact survival trait applies to Comfy UI today. The payoff for accepting this expanded role is a multimodal production studio capable of video, audio, still images, and upscaling, all running locally on a single consumer GPU with 0 external API dependencies. The line between artist and systems engineer has blurred. The true limitation in generative AI is no longer the VRAM on the graphics card, but the operator's willingness to cross that line.